Hi everyone, this is a video about triangle congruency and it's the bulk of chapter 4. So to get started, let's talk about congruency. What does it mean to be congruent? Well, let's draw two shapes. Let's do circles. Are these two shapes congruent? No. Why? Well, congruent means to have the same size and the same shape. And these two circles aren't congruent because they're not the same size, but they are the same shape. So just to write it down, alright, so there are a couple types of triangle congruency. We have side, 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 angle, side, angle, side, angle, and angle, angle, side. And it's an important note that side, side, angle is not a rule. Now let's talk about what do these things mean. It's just a long string of different letters. What do these things actually mean? So let's delve into it. You have, okay, hold on. You have two triangles. Say they both, you know what? Say they both have like the same shape, and they look like they have the same shape. They look almost identical, but they have no indicator whether they are congruent or they're not. So how can we prove that triangles are congruent? Well, you'll see these little tick mark thingies, and these things determine basically what is congruent. So this one tick and this one tick, that means these two sides are congruent. And that means this side and this side are congruent. And this side and this side are also congruent. Okay, so what? They're congruent. Okay, so to prove this, you would use one of the things called side, side, side. And this basically means that all sides are congruent, therefore the entire triangle is congruent. Well, like both triangles are congruent. So now what? What about everything else? So let's talk about side, angle, side. Side, angle, side is an interesting one because it does have a very specific rule to it. So basically this side, and this side, this side, and this side, but this angle and this angle. There's a reason why it's ordered in this specific way. So side, angle, side. And that's because the angle has to be between the two sides, because if it's anywhere else, let's say the angle is there, it doesn't matter if those two sides are equal, because if this and this are, well, okay, hold on. This and this are equal, but the issue is it doesn't change no matter how much you stretch or elevate it. That's determining the angle. So it's still the same if I move it and decrease the angle. But these two triangles aren't congruent because they're not the same shape or the same size. And that is also why side-side angle is not a rule. So this has a specific rule to it where the angle has to be between the two sides. And using that, you can prove the two triangles are congruent. For our next one, angle-side angle also has a rule, but it doesn't really matter because these two rules are synonymous, except it's just where you put your angle. So if this angle and this angle are congruent, and you'll also see these little tick marks on your angle, or it could be like a double line kind of thing. But either way is fine. So this is angle side angle because your angle and then your side and then your angle. And this is one of the congruency rules. However, you can still have the angles somewhere else. It's not that congruency rule. Instead, this is just angle, angle, side, or side, angle, angle, depending on which way you want to put it. But that's also a rule. It just depends on the location of your side or the location of your angles. And then the most important is that side-side angle is not a rule unless you have a right triangle. Now this is a very interesting thing because before we would just have two, like one angle and two sides and undetermined angles everywhere. But once it's a right triangle, if you know this angle and then you have two sides, the hypotenuse is going to be the same every time. Why? It's based on the Pythagorean theorem, of course. A squared plus b squared equals c squared. So if this side is 4 and this side is 3, the hypotenuse is always going to be 5 no matter what the angle is. So if this angle and this angle are equal, and of course these two sides are also congruent, that means these two triangles are congruent. But this only works for right triangles. Now there are different types of labeling for these right triangle congruencies. So this specific congruency rule is called hypotenuse leg. It's weird, I know. For side, 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 triangle congruency is called leg, leg. For angle, angle, side, the hypotenuse is hypotenuse angle. For side, angle, side, it's leg and angle. And then you have hypotenuse leg. So let's get into some work. Now we're going to see what makes these triangles congruent. So let's go through this. We have two legs, but we don't know if this is a right triangle. So what are we going to do? because we only have two determined sides. Well, you see this third side is shared. So that's what that little s means. It means that that side is common shared, and it means that it's equal. So now we know that there's three congruent sides. So this is by S, S, S. What about this one? We can use our knowledge of angles to determine this. So we automatically know that this equals this. And seeing that it's two parallel lines, we know that this equals this. So finally, using sum of angles in a triangle, we would know that this angle equals this. But just because these two sides are parallel doesn't make them equal. So we only know that it's angle, angle, angle. But angle, angle, angle is not a rule. So what rule do we use? We don't use one. Because of something called similar triangles, where it is the same shape, but it's not the same size. So each side is in proportion. That's like 2x, that would be x. These sides are proportion, the proportion is 2 to 1, or 1 to 2, depending on how you look at it. And that's only if the angles are congruent. But since only the angles are congruent and none of the sides are, it's just angle, 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 and there is no congruency rule. So for this one, we have our shared common side again, and that's all we know. So we have two angles. Seeing that it's a right triangle, we're going to use the right triangle congruency rules. So let's go back up here and let's see what it is. First, let's determine what it is. We have angle, angle, side. So what does that translate to? It translates to hypotenuse, angle. So we're going to call it hypotenuse angle. Now for this next one, we have a base. Split in two. And then we have a right triangle, we have two right triangles. And then we have a shared common side. So that's side, angle, side. And that's going to be leg, angle. Now for this final one, we have a shared common side, and then we have angles. And notice how these angles are on the shared common side, which is the congruent side. So now what are we going to do? What is this? This is angle, side, angle. And now I'm just going to take one of these and I'm going to do a proof for you, because proofs seem to be a lot of people's least favorite thing in the world. And I totally get that. So just to make it nice and easy for everyone, we're going to start a proof. So I'm just naming the sides A, B, C, D so we can get started. The black tick marks mean that it's given. So let's go through some. Given, all right, now let's prove ABD and CBD Sorry, I named the triangle wrong. I meant ACD are equal. Now, I didn't check if I named these correctly, but what you want to do is just to make sure that the congruent sides line up when you name it. So AB is congruent to AC, which checks out. ABD, and then I did ACD. So this is named correctly. Now let's prove it using statements and reasons. The trick to doing these to make it less horrible and tedious is to just start with your given. So you're going to do AB equals AC. Cool. Our reason is that it's given. And just as a tip on the side, don't try remembering all the theorems and all the corollaries and all these random, just theorems and whatever. Just try to understand the material. So once you write your statements and reasons, those things will come to you so you don't have to remember and recall. So anyway, CD equals DB, which is also given. And then let's start by saying AD equals DA, which is reflexive. Why are we using this property? Well, AD equals DA, we're just saying that so that you understand that that is the shared common side. So once we have all three of our sides proven, we can state it. So triangle ABD, I forgot to put the squiggles, but equals is the same as congruent, but we're proving congruency, so we're just going to use the congruent symbol. So ABD is congruent to triangle ACD. And that's by rule side, side, side. So that'll be it for this video. And just don't hesitate to ask any questions.